Emiliano Cevenini. I'm responsible for the commercial and industrial vertical market for Vertiv. This is a new route to market for Vertiv, where we are addressing our customer needs, following up the segment rather than the product or the service. And we have, let's say, four main verticals: hyperscale and colocation, telecommunication, heavy industrial, and commercial and light industrial, which I'm leading to. And the critical energy initiatives within Vertiv are sitting in the commercial and light industrial.
Devrim Celal, Chief Executive Officer, Upside Energy. Upside is an award-winning cloud platform that uses advanced algorithms and artificial intelligence to help manage and optimize very large, diverse portfolios of energy assets for our customers. So it's interesting. We've got two models of going to market. Our main model is what we're talking about here with Vertiv, is where we support a third party who either manufactures those assets or sometimes utilities who have supply customers where they want to be able to control the load of those assets. I believe so. Probably Emiliano could give you more depth on that one.
Well, certainly I would say yes and no. Well, first of all, because I could say that initially this was not our idea, because this was an idea of one of our customers, a data center customer, who came to us and say, I would like you to enable my battery assets to do something more and participate into the balancing markets, and I would like you to provide me a solution. And at the same time, we had the possibility to work to battery energy storage front of the meter with a big installation here in UK, a 20 megawatts battery energy storage, providing enhanced frequency regulation services. And we provided a solution for that. So we started to learn about how to use our technology instead of using it only load side, so for protecting the downstream load, also to do something useful upstream. And then it came this data center customer who asked us, do you have this solution, this technology? And we are actually providing and doing field trials with this data center customer. Then we met with Upside Energy, and we also worked with a project together just to say prove the concept. And we have already this first connected customer, which is not purely an hyperscale, it's not an hyperscale data center, but it's, I would say, a mixed customer having distributed application and central data center, so a mix of the two, and it works. So that's why we had the idea of the platform and the Vertiv Energy Storage, the Vertiv Energy Store, which is based on the Upside engine, the virtual energy store. This was the birth of the idea and how we developed it.
A long time to get the first data center customer online delivering revenue. That's happening now. The customer is quite happy. So I expect that we'll be able to release a case study on this within a month or so. So watch this space. So the really high-level response to that is by providing power, you're making the grid more stable. The more pragmatic is, no matter what we do with your systems, we always leave enough energy in the system that if something goes wrong after we're done, you're pretty well backed up and you wouldn't run into any trouble. And that level, the state of charge, so we go down to 80%, that's totally in your control. So if you want to leave us at 90%, that's fine. If you want us to go down to 70%, that's fine as well. But you decide how much you want to put at risk by that definition. So the more depth of discharge, the higher the returns to the asset owner. It's more a question driven by the sense of security of having that energy always available, but also looking at the battery chemistry and making sure that the actions we're taking are within the operational parameters of that chemistry. So one of the things we do is asset management. So if it's all the case we talked about so far has been lead acid, where you don't want to deep discharge and cycle them too often. But with the case of lithium ion, you actually have to cycle them. And that's the mode of the battery. It needs to be cycled to keep its health. So we manage that as a platform. So if we could demonstrate on the platform, it's actually quite pretty in the way it demonstrates. You never drain one battery at a time. You're constantly taking a little bit from all the batteries and stacking the virtual power from that to deliver a service. Therefore, you never overdrain a single battery. It's a statistical algorithm that's patented that drives the equal use of energy. I wish it could be more, but the grid will tell you they are a regulated monopoly and they need to make sure that the British consumer gets the best deal. So it's a marketplace that we bid into. There is downward pressure on the prices, especially we're talking here frequency response type services. However, we believe by having a dynamic optimization platform, in real time you can pick the most valuable markets to put the capacity into, and that way constantly maintain a healthy rate of return for customers.
I think this is one of the most important features of this partnership, is that we completely offer to the customer a package which filters the market aspect data. So this is really for experts, and it is country dependent, as we're saying. So it is for companies like Upside who know the market inside out, to deal with the opportunities, to aggregate the assets, to do a fair share of breakdown of things to be done, of discharges, and manage the fleet, let's say, of devices. We as Vertiv, we are having the relationship with the customer. So essentially, today, we are responsible, technically responsible, for the performance in our installations. By adding this communication capability, we are actually not changing the mission. We are adding another possibility. Okay. Also, we have an internal safeguard as well for the state of charge. So, literally, the state of charge is not entirely available to the platform. So it is not entirely available to the cloud engine, let's say, to the dispatching engine, but there is a hard safeguard into the UPS. Now, the amount of these percentage, say how much of my battery can I devote to this service, this very much depends on the type of battery and on the sizing of battery. If we have the most typical UPS customer with lead acid battery, we will use the 20% because we cannot afford many deep discharge cycles. We can afford shallow discharge cycles, not so frequent, and managed as a fleet. Okay? The more alternative or new battery storage, such as the lithium-ion batteries, penetrates also the UPS applications, they can withstand a higher number of cycles with a deeper discharge. So we could lower that percentage of the safeguard, let's say, and using more of the battery. This clearly impacts the way you size the battery. Now you have a real case. The case is it's an incremental business case for our customers, where the incremental capex or the incremental investment is on the part of the battery which will be traded by the platform. Okay? And the return comes from the optimization of the revenues coming from the battery. The idea is that, let's say, Upside plays on the market and optimize as much as possible the revenues. We are the primary responsible for the overall functioning of the site and of the primary mission of our devices, and we share the value with our customers. So our customers have a direct advantage in a participation in this value generation. Completely safe from the primary mission standpoint, no sunk costs, because managing contracts with these controlled monopolies can be complex, let's say. For a customer like a data center operator, this can be a sunk cost. no sunk costs here because it's all evident, it's all managed.
We could retrofit a solution. Depends on how old the UPS is to start off with, but in most cases we can retrofit. The first step is just a site inspection, just to understand what's there and how it could be integrated. The next step, depending on how old your UPS is, let's say it's a fairly recent UPS, we'll have to install what we call a gateway box, which enables communication between the UPS and the cloud platform. And from that point on is really agreeing the operational parameters, how much of the battery to use, how often. We will use that to give you an idea of the possible returns under those scenarios. And when you're happy, we press the go button and that's it. We start making money the next month.
I think that there is a very important element here. We are not only talking about new installations. We do have today the possibility of retrofitting legacy installation, the installed base, not the very old ones, because our devices can have a useful life of more than 20 years, 25 years, of course, not devices of that age, let's say, but the installed base of a few years ago can be retrofitted and enabled and connected to the platform. So literally for these customers, we need to evaluate the state of health of the battery. If the battery is okay, we can, let's say, go on site, install the gateway, connect to the platform, and that's it. So it's a great opportunity for our installed base as well.
Our first big deployment was communication tower, backup power. We've done a few universities, ranging from their backing up their networks. So the applications are any.
I think that especially telecommunication, definitely our telecom customers, we are talking with them, with a few selected. They are very interested. I would say that also, for example, for retail, this is a great opportunity. Retail is a typical customer where there are regional distribution centers and the shops with, of course, the smaller power, but that's a perfect environment to be aggregated.
Go back to real tangible numbers. So National Grid commissioned a report, I believe it was in 2016 or 17, to look at the impact of delivering frequency response using existing assets or batteries. And the outcome of that was about, they estimated for each megawatt managed in this method would save about 600 metric tons of carbon dioxide emissions every year. So in a way, you're providing a mechanism for grid to absorb more renewables into its system while curtailing coal generation from delivering this balancing service. Connectivity is the thing of this age. Everything is connected. So that's a problem that you will face in every facet of business. And all you can do is make sure you have the most secure system and keep updating it, because hackers will catch up at some point. So in our case, we use a existing protocol. Everything is built on an existing communication protocol, which was designed for demand response. We initiate communication from the device end, and it calls up to a RESTful API on the cloud. And what that basically says, and it's a mutual authentication end to end. What that says is, if someone else tries to break into that line and communicate with the asset doesn't accept any incoming calls. It's only configured to call to a single address in the cloud. So that's one level of security that also allows you to keep all existing firewalls in place because you don't need to make any changes. And on top of that, we have ethical hackers constantly monitoring and trying to hack our system. So I was looking at numbers earlier today. Data centers by 2025 will be consuming 20% of the energy produced in the world. Therefore, to me, data centers are the ideal customers for this, because just by providing the flexibility they have in their systems, it will help solve a lot of the problems that we'll be creating for the next 10 years.
Certainly, there are hyperscale data centers. They are the usual suspects, let's say, who are, of course, they have their own ideas on generating their own electricity, but there will be a vast majority of data centers connected to the grid. And I believe that this is a proposal, and we can demonstrate that this is a proposal for any kind of criticality of data centers. It's not just for a type of data center, but this is for hyperscale, for telecommunication nodes, for co-location. It's very interesting. Actually, it is a proposal first and foremost for the CFO of the data center, because this is about either cost saving on the energy bill, and the energy bill is a big, probably the biggest OPEX of a data center, and extra revenues. So with the probably minimal marginal capex investment, if we will not go for as a service, we might decide in the future, when this is catching up, to go with as a service. So for example, providing the battery as a service, that could be a possibility. That will further help the business case, but it's all about business case. So it's not just, it is certainly to save CO2, it is certainly to help the grids in managing the renewables, but at the end of the day, today is a financial proposal, a positive NPV proposal to our customers.